Good morning, everyone. Kevin and I will present our paper exploring large language models for irony detection in 19th century Spanish. This work is part of Kevin's computer science master dissertation, and it is also part of my doctoral research, which aims to explore how AI can help us better understand the history of emotions in 19th century Latin America. Let's start by reflecting on a very complex form of communication, irony. Irony is a linguistic and emotional phenomenon occurring when someone intentionally says something different or even opposite to what they actually mean. It can be critical, political, subversive, or culturally revealing, but usually it intends to be humorous. Irony communicates deep emotional layers and social messages that often cannot be expressed directly, particularly in public or politically constrained contexts. For humanities scholars, understanding irony in historical text is essential because irony can reveal hidden tensions and emotional landscape significant to a specific historical moment. Irony can offer subtle insights into the feelings and perspective of historical actors who could otherwise never directly speak their true thoughts and emotions. Detecting irony is very challenging, not only for historians but also for NLP researchers. Irony represents a significant problem. Traditional sentiment analysis models usually classify emotions simply as positive, negative, or neutral, but irony often resists fitting into these categories. NLP researchers have achieved promising but still limited results. The central obstacle has been understanding not only the linguistic aspect of irony, but also its deep contextual roots. Irony highly depends on culture, knowledge of historical events, and interpreting the social circumstances of the time it was written or produced. And this is precisely where our research makes its contribution. Our work presents two novel contributions: a dataset tagged for irony and sentiment detection, but we also proposed a semi-automated annotation methodology where human expertise is crucial for refining LLM results, enriched by incorporating historical and cultural context as core features. All of our results are published in the links previously that you saw. Now I will explain the data sources that we have used in our experiments with LLMs. We start from a dataset named LATAM19, included in one of our previous work. It is composed by roughly 23,000 pages of 197 newspapers of digitized images, mainly from Mexico, but also from other Latin American countries. And then we select randomly 2,700 entries comprise manually tagged corpus. We tagged four categories: irony, positive, negative, and neutral. And then we made a copy of that data set to transform it into binary classification, which means irony or not irony detection. Now, Kevin will take you into deeper methodology and the main findings.
Thanks, Laura. Now, let's start with what was done in this research. First, we would like to give you clarity about the most important experiments done during the research. As the slide shows, we wanted to identify irony in the 19th century Latin American text by using LLMs. We then planned the following experiments. First, the baseline. For this, we used straightforward GPT for classification and developed a classification pipeline for using BERT models within the task. Second, the automatic dataset enhancing that looked forward to experimenting with the capabilities of LLMs to improve context and sentiment cues for irony detection. And lastly, the semi-automatic dataset augmentation that explored the possibility of augmenting a base dataset with the help of experts and LLMs. In a more detailed approach to the baseline, the experiment consisted in two aspects. The first, that was the GPT-4o classification, consisted in classifying the entries in the primary dataset using only the LLM capabilities, and a well-crafted prompt. More details of this prompt in the following sections. Then, the answers were processed using regular expressions and properly evaluated. The second was the BERT classification pipeline, that based on the CLS token generation, different BERT-based models were fine-tuned with the primary dataset, producing models capable to classify sentiment. These models could be trained for binary or multi-class classification as seen in the graph. This baseline particularly will be used as a base for the following experiments, as them mainly focus on the dataset itself. The models used were these, that you can find openly in Hugging Face. The Better Case Fine-Tuned 19 LATAM model was previously pre-trained in other research from Historical Inc., so its knowledge from 19th century Latin American texts is better than the others. For the second experiment, that was automatic dataset enhancing, it consisted in evaluating the hypothesis that LLMs, specifically GPT-4o, could enhance the original text to facilitate classification. So, with the objective in mind, the prompt you can see in the screen was developed. As a clarification, this and any other prompt used was done originally in Spanish, but for the sake of your better understanding, it was translated to English. This prompt instructed the model to grab the original text and enhance the context, as in historical information related to the text and sentiment cues, trying to facilitate the process of detection of irony. The result of the process was the called enhanced dataset that was then used with the previously exposed baseline for developing a new model. The third and last experiment was the semi-automatic dataset augmentation. This experiment was done for testing the hypothesis that LLMs could help augment the dataset through a semi-automatic annotation process. The diagram shows the pipeline for this process. First, the previously exposed untagged dataset is passed through the GPT-4 with a well-crafted prompt. More on this matter in the following slide. The resulting dataset is then evaluated by experts in history, like my colleague Laura, that reviewed the responses of the model and corrected, if necessary, those entries. All of these entries produce a new tagged dataset. This dataset is then added to the primary dataset and results in the new augmented dataset. As in the previous experiment, this dataset is used with the baseline for classification. As said before, now this is a more detailed description of the prompt used. It is made of four key components. First, context. A short introduction of the 19th century Latin American origin of the text is provided to the prompt. Second, irony recognition. Three scenarios were explained for possible irony: contradictions between the described reality and expression, a contradiction between historical reality and expression, and a contradiction between the expression tone, as indicated between capitalization and punctuation. Then, three exceptions. These cases are not classified as irony, yet could be confused as such, so they are explicitly stated. We're talking about political opinions, poetic language, and instances lacking humorous intent. And finally, the task that is enunciated in the prompt, that is to classify between one of the four classes, and the explanation of that classification should be introduced between asterisks. Now, we'll go with the results of the experiments. Firstly, the results for the GPT-4o baseline were as expected, not good. As you can see, the model had trouble classifying almost everything, especially when the classification was multi-class. A high recall in the irony class tells us that maybe there is a high tendency for the model to classify into irony, yet we can see that it's not very good at it. We can also appreciate a tendency that will be seen in all experiments. The binary classification got a better general accuracy. For the BERT-based baseline, these were the best performing models. Now, the results were better than only with GPT-4o. Specifically, with the irony, we can see that precision increased significantly, yet recall decreased. This classification is a little more reliable than before, but still lacks consistency. Most of the irony instances are still out of reach for the models. Now, for dataset enhancing, the results were not as expected. In previous work, authors stated that the strategy had improved significantly the model's performance, yet it wasn't the case for our dataset. The models presented are the better performing ones too, but the values only improved slightly, not enough to consider this a success, only a not so great middle step. Lastly, the dataset augmentation experiment, the results were the best. As you can see, both precision and recall improved significantly for the irony class, yet reducing slightly the performance for the other classes. With this, we can state that the dataset augmentation is the more effective experiment we have done. Lastly, the binary classification results were the ones with the best model outputs. At last, Vero-based Spanish case obtained the best performance, being a reliable alternative to irony detection in this context. Now, Laura will talk about the discussion of these results.
Okay, so overall, GPT performed quite effectively when generating text for irony, but we verified with three other experts, and this human intervention proved essential. In fact, there are some limitations that we identify, especially when a deeper historical or cultural context was required to understand this nuanced type of irony. This highlights again how irony is closely tied to historical circumstances and specific cultural symbolic meaning, making it challenging for AI models alone to capture fully the irony detection. Okay, so for example, GPT-4o struggled to identify irony specifically when applying enhancement techniques to a sentence expressing political contradictions during the Porfiriato in Mexico, primarily due to a lack of historical context. Porfirio Diaz, a former Mexican president, initially opposed to re-elections, citing constitutional violation, but he ironically remained in power for 35 years. Enhancing the text did not effectively capture the specific cultural and historical features present in some historical texts as this one. This highlights the cultural bias embedded in commercial models such as GPT-4o, emphasizing the need for more tailored approach and using also mixed methods, which means combining both qualitative and quantitative methods. It was also clear that textual irony alone was not sufficient for fully capturing people's deeper emotional experiences. Our work strongly suggests that there's great potential by incorporating multimodal analysis, particularly images, to enrich irony recognition. Irony expressed visually, as in political cartoons, adds layers of meaning that pure text analysis cannot fully decode. To illustrate precisely this point, let me share with you one very striking example. The caricature you're seeing right now on the screen was generated by GPT, prompt to reflect current international political tension. Take a moment to observe it. If you were a future historian 550 years from now, you can tell the difference of appreciating this cartoon. To fully grasp its ironic significance, one must be informed of the broader social and political context of this precise moment in time, and also to feel the emotions communicated by it. Understanding the historical context of irony allow us not only intellectually to understand it, but also emotionally to resonate with the deeper messages encoded within. Therefore, one of our main conclusions of this work is that irony detection for historical and cultural analysis can benefit significantly for NLP approaches, integrating historical documents in the training of the models, the expert in the loop during the experiments, and finally, mixed methods. Thank you very much.
Thanks for your attention.